The Platform Management User Interface helps you to manage the devices connected to an oktoflow instance, create new applications, and run those applications in the platform. Before we start, we should set up our machine with the prerequisites and the integrated development environment (IDE) needed for the development of a new application. To set up your machine without using a Docker container, you should follow the installation guide, install.md. You might use the ready-to-use Docker development container of the platform, devcontainer.md. We will skip this setup since it is not the scope of the video, and we will use the ready-to-use Docker development container. On the Management User Interface, we have three main tabs. Resources, to manage the connected devices. Configuration, to create new and to modify existing applications. Runtime, to start, monitor and stop applications. Our focus on this video will be on how to create a new application from scratch using the user interface of oktoflow. This complements an already published ReGaP video, where the application was created by modifying one of oktoflow's examples, in particular by directly changing the configuration model and by running all build processes manually. The most relevant tab for developing an app is the Configuration tab. The Configuration tab has a normal mode to focus on particular aspects that you need to create basic applications, as well as an expert mode to dive deep into creating complex applications. To create an application in oktoflow, we need the following aspects. Types, to characterize the data that is received from external sources, flowing through services of an application, and, usually, emitted to external sinks. Services, to represent a unit of work, which receives data and produces results, for example by transforming or augmenting received data. The unit of work may be predefined by the platform, like connectors communicating with external entities using a specific protocol, like OPC UA or MQTT. A unit of work can also be realized in terms of a service using your own program code in Java or Python. Meshes, to model the data flow among units of work, that is, connectors and services, in terms of graph elements like data sources, data processors, and data receivers. Applications, to tie everything together. In this step, we will be able to obtain a code template for implementing our services and to upload implemented services into the platform to automatically integrate them into a complete application. As an example, we will create the same application as done in the ReGaP video on how to integrate AI services into an oktoflow application. The slide shows the data flow for the application starting from a source service that ingests data. In turn, the data is processed by the Python AI service and finally sent to the Syn Java service. The sync service writes the received data to the console. The first step of creating an application is to create types to characterize the data transfer between services or connectors. These types are expressed as so-called record types, a complex type with multiple typed fields. There are many predefined primitive types, such as string or integer, that you can use to create your record types. To create a record type, please select the Types tab on the screen. Then, select the type to be created, which is record type, and click on the Create button, the plus symbol. The dialog shows all configuration options for the type. Add the unique name of the record type, then the fields the record type consists of. For our application, we need in the first type Centron output consist of 13 fields. We omit the rest of the fields since entering them is always the same procedure. After that, we will enter the second record type, that is, AI Centron output consists of 15 fields, which we will also omit in this video. A service is a unit of work that receives data and produces results. There are predefined services by the platform, like connectors, or, for performing special tasks, you might implement a new service using Java or Python. To create a service, select the Services tab on the screen. Then, select the type of service you would like to create and click on the Create button, the plus symbol. In our example, there is a connector, a Python service, and a Java service. We will now create the Centron Modbus connector. The dialog shows the configuration options for the service. We enter the mandatory basic information like name or version. We also have to enter the artifact where the implementation of the service will be found later. We will explain artifact names in a few seconds. The host in the Centron Modbus connector specifies the machine's IP address where the Modbus server is running. As we do not have a machine available that provides a Modbus server for us, we will mock the machine, that is, we will use data replay instead of the real machine. For this, we keep the IP address as localhost and set mock to true. We do the same for the other services, that is, we define example Python service as Python service and receiver as Java service. As those services will process receive data without external connections, we do not need to specify an IP address or the mocking flag. An artifact contains one or multiple implementation files. Regardless of the programming language, the artifact is in oktoflow always a so-called Maven coordinate, a unique identification of the Maven build system. A Maven coordinate consists of a group identifier, an artifact identifier and a version. In this example, we will use de.ipecosphere.platform.apps as group identifier, the name of the application postfixed by the word services as artifact identifier and, akin to oktoflow's actual version, 0.7.1, snapshot as version. The individual parts of a Maven coordinate are separated by colons, that is, the complete value will be de.ipecosphere.platform.apps ReGaP app services 0.7.1 snapshot. Actually, a snapshot is an artifact that is still subject to change. If we would use a version number without snapshot, it would be a release artifact that could no longer be modified. A mesh represents the data flow between the services. For our application, we will link the services, that is, the units of work among each other using data flows. To create a mesh, select the Meshes tab on the screen. Click on the Create button, the plus symbol. The screen will now show the available services on the left side and an empty area to create the mesh on the right side. To add a service to the mesh, first click once on an available service on the left side, we select Centron Modbus and click then another time on the mesh area on the right side to place the service. Similarly, we also add example Python service and receiver. Then connect the services by data flows like this. Services can only be connected if their output and input data types match. Finally, add the name of the mesh and click on Create. Ultimately, we need an application to package related types, services, and meshes. To create an application, select the Applications tab on the screen. Click on the Create button, the plus symbol. The dialog will show the configurable options for an application. Fill the fields, in particular name, version, and the meshes that belong to the application. Please note that here the name of the application and the version will form the default artifact identifier of the services. The application is now completely specified. However, the implementation our specific services, that is, Python and Java service, are still missing. To ease the implementation of services, oktoflow allows for generating and downloading an application code template. On the same tab, the Application tab, click on the Generate Application Template button, the angle bracket symbol. Wait until the generation is completed. We omit the waiting part. We click on the pop-up message to download the application code template, which is actually a project that can be used in usual integrated development environments such as Eclipse or Visual Studio Code. We will use Eclipse in this video. Open the Eclipse IDE provided in the container and create a new project based on the application code template. Import the downloaded zip file into the new project and, yes to all, allow to overwrite all existing files. Then, update the Maven project. As in the previous video, you will find the services in the files receiver.impl.java and example Python service.py, respectively. Open the template for each service and modify them accordingly. We take over the code parts from the previous video into appropriate locations for Java and Python. We omit details of the copy actions here. Then, save the files. Run the build process once so that you are at least sure that there are no syntax errors in your code. We recommend to test the services individually using unit tests. The template also contains unit test code templates, which are not active by default as they require service-specific test data. However, to keep the video short, we will skip the tests here. In contrast to the previous video, the build process of an application code template just focuses on the services. That is, it runs a bit faster. Typically, an IDE indicates problems such as syntax errors or missing dependencies. To be absolutely certain that the project doesn't have any such errors and that the services are likely to work correctly, we now run the build process. This also executes the service tests. Therefore, we run depending on your operating system, build.sh or build.bat in a console in the project folder. To be extra cautious, we specify that clean our argument so that any previous build information is deleted at the beginning of the build process. If you plan to implement the tests later or you are still implementing the tests, you can temporarily disable their execution using the deskiptests argument. However, we recommend to not disable the tests carelessly, as they can uncover fundamental problems that might otherwise only pop up during the app's runtime and then require us to repeat the following steps. However, we now have the services ready but no application that executes the services. To achieve this, export the project as a zip file and let oktoflow integrate the services into the previously specified application. One way is to upload the implemented services, which we will show now. On the same tab, Application tab, click on the Upload button, the up arrow symbol. Select the exported zip file containing the service implementations and upload the file. Wait until the upload is completed. On the same tab, Application tab, click on the Integrate Application button, the flight takeoff symbol. Wait until the integrated application is completed. We omit the waiting part. Now the application is created successfully and ready to use. It is already deployed into the platform instance and could be started there. However, this needs a deployment plan as oktoflow typically runs applications in distributed fashion. We will show in a future video how to create a deployment plan using the management UI. Alternatively, we can run the application through the generated build process of the application code template. This step will download the integrated application from the platform and execute it. As the platform and its communication broker is running in the development container, we do not need to specifically start a broker instance as shown in the previous video. For this purpose, we execute depending on your operating system either the generated run.sh or run.bat script in the template project in a console. Besides creating more complex applications, there are many more options to explore. We will introduce some of these options in the next videos.